This is section 4.9 on antiderivatives. Okay, so 4.9, which in my opinion should actually belong with chapter 5, so we can get this focus here. So we have 1 to 47 odd and 59 to 63 odd. Let me show that to you right now. Topic is antiderivatives. Here. If it sounds like derivatives backwards, it is. Okay, so 4.9 antiderivatives, page 350. Our homework, page 355. 1 to 11, 13 through 21. So you're back 1 to 11 again. And you can't quite see the bottom because it's up against the document camera here, so I have to tilt the book. Page 356, some on here. So it looks like they're giving us the derivative or even second derivative. We're going backwards. So up to now, we start off with a function and you come back with the derivative or second derivative. And now we're going the other way. Start off with a derivative or second derivative, come back with the original function. Okay. So notation. You see this funny looking S, f of x, and a dx. We read it the integral of f of x dx. Okay, this is called the integral sign or integral symbol. It means give a class of antiderivatives of f of x. Okay, so integration means anti-differentiation. Okay, so for us, when you hear integration, yes, it has its own English meaning, but in math, integration means anti-differentiation. But look at how big the word anti-differentiation is. That's too big, so we want to say integration. All right, so 4.9 number 1, the integral of 4x plus 7 dx means give a class of antiderivatives, a whole bunch of antiderivatives of the function. Notice in general, it looks like the answer has a plus c, and we'll talk about that in a moment. Okay, here's the answer right now without even me telling you how to do it yet. The answer is 2x squared plus 7x plus c. C stands for constant, where c can be 0, 1, 2, -1, -2, -80, a million, pi, e, any real number that you want. All of these functions, plural, have the property that the derivative of any of these functions is 4x plus 7, right? Derivative of 2x squared is 4x, derivative of 7x is 7. And you can pick any constant you want because the derivative of any constant is 0. Okay. Number 9, integral of square root of 2 dx. Okay, so what does a dx do? Well, right now it doesn't do anything. It just names what the antiderivative is for the variable. The answer is square root of 2x plus c. That includes square root of 2x, square root of 2x plus 1, minus 1, minus a million. Okay, c can be any constant, any real number. The derivative of any of these functions is radical 2. So the first thing to notice is whereas before there was only one derivative, we have many antiderivatives potentially, right? But they all differ by a constant. Okay, 17, integral of 2 sine theta minus secant squared theta d theta. D theta names the variable. Okay, here's the answer, then we'll talk about how you get it. Okay, although in some instances you might think, well, you just kind of go backwards from the derivative. Okay, -2 cosine theta minus tangent theta plus c. Okay, so you can check your answer by differentiation, right? What's the derivative of this? Well, the derivative of -2 cosine theta is positive 2 sine theta. The derivative of negative tangent theta is negative secant squared theta, and the derivative of any constant is 0, so it works. All right, so the first thing we want to do is come up with the power rule, which is exactly backwards for the power rule of derivatives. Okay, so for the power rule for derivatives, you multiply it by the exponent and subtracted 1. So guess what happens here? You add 1 and you divide by the new exponent. So the integral of x to the n dx is x to the n plus 1 over n plus 1 plus a constant where n is not equal to -1. Of course, n cannot be -1 because then you'll be divided by 0. A simple example is what's the integral of x dx? X is like x to the 1, so x squared over 2 plus c. You can always double check your answer by differentiation. What's the derivative of this? Well, 2 comes down, knocks out the 2, you have x to the 1 or x, and the derivative of any constant is 0. Okay, and you might be wondering what happens if I do have a negative 1. So the integral of x to the negative 1 dx is not x to the 0 over 0. Instead, we call that x to the negative 1 means 1 over x dx, and the integral of 1 over x is ln absolute value of x plus c. You might recall a while back we said the derivative of ln absolute value of x is 1 over x. So the integral of 1 over x dx is ln absolute value of x plus c. Okay. All right, 15. In case you're wondering, there is no such thing as a product rule. There's no such thing as a quotient rule for integrals. So we have to do something else. In fact, a major topic of Calc 2 is integrating and differentiating when you have products and quotients. You kind of wish you could say, why don't I just do the product rule? Why don't I just do the quotient rule? Simple. There is no product rule. There is no quotient rule. So you can't say, if I have a product, I will always do this. Or if I have a quotient, I will always do this. Doesn't work here. But in this case, all I can do is divide. So divide 1 by radical t is t to the negative half. T to the 1 divided by t to the half is t to the half. And t squared divided by t to the half is t to the 3 halves. Now I do my power rule. You add 1 and divide by the new exponent. So t to the half divided by half, t to the 3 halves over 3 halves, t to the 5 halves over 5 halves plus c. Okay. And you should know that if you divide by a fraction, you multiply by the reciprocal. So most of the time, when I have a fractional division like this, I'll immediately go to multiplying by the reciprocal. That's just arithmetic. You're all very good at arithmetic because you're in calculus. So I'll make the assumption you know what I do. Instead of dividing by a fraction, I'll go quickly to multiplying by the reciprocal. So 2 radical t plus 2/3 t to the 3 halves plus 2/5 t to the 5 halves plus c. Reciprocate, reciprocate, reciprocate. Okay, 19. 2 to the x, integral of 2 to the x plus 4 sinh x dx. Okay, so that's logic backwards. What was the derivative of 2 to the x? 2 to the x ln 2. You multiply by ln 2. So guess what happens when you integrate? Since integration and differentiation are opposite operations, you divide by ln 2. So the integral is 2 to the x ln 2 plus 4. Integral of sinh is cosh because the derivative of cosh is sinh plus c. All right, now we're going to get some problems where you'll be asked to find c. So your final answer is not plus c, but you'll figure out the c. That's when they give you extra information like this, f of 0 equals 4. Okay, now if they only give me this, then it's just like all the other problems. I just anti-differentiate. But they tell me capital F of 0 is 4, where capital F is an antiderivative. Okay, so I anti-differentiate, integrate. 5x to the 4th minus 2x to the 5th dx. Okay, 5x to the 5th over 5 minus 2x to the 6th over 6. X to the 5th minus 1/3 x to the 6th plus c is capital F of x. You can double check. What's the derivative of that? 5x to the 4th. What's the derivative of that? 6 times negative 1/3 is negative 2, x to the 5th. Derivative of a constant is 0. Now, to find the c, I plug in 0 for x, and the answer comes out to be 4. So 4 is the answer when I put 0 there and 0 there. Well, that's 0 and that's 0. So c is 4. So this time, the one and only one answer is f of x is x to the 5th minus 1/3 x to the 6th plus 4. So in this case, you will be able to find the value of c. Okay, 25, you have the second derivative. The second derivative is this, find the original function. So that's backwards of what we've been doing a lot in this course, right? So right now, here's a function. Here's the first derivative. Here's the second derivative. Now we're going backwards. Here's the second derivative. What was the first derivative? What was the original function? So f prime is the integral of 20x cubed minus 12x squared plus 6x, which is 20x to the 4th over 4, power root, minus 12x cubed over 3, plus 6x squared over 2, plus c1. I have to write c1 because there's going to be a c2 also. 5x to the 4th minus 4x cubed plus 3x squared plus c1. By the way, double check. What's the derivative of this guy? Right? Is the derivative of that? Yes. Is the derivative of that? Yes. Is the derivative of that? Yes. Is the derivative of any constant 0? Yes, it is. Okay, so that's f prime. So I integrate one more time to get f of x. So integrate this thing. Integral of this is 5x to the 5th over 5 minus 4x to the 4th over 4 plus 3x cubed over 3. The integral of c1 is c1x. Derivative of a constant, integral of 3 is 3x. Integral of c1 is c1x plus another constant c2. And notice a nice cancellation. X to the 5th minus x to the 4th plus x cubed plus c1x plus c2. So here's a whole family of functions Just give me a different C1, a different C2. I have a different solution. All of these functions have the property that the second derivative comes out to be that. Okay. F triple prime, oh boy. 12 plus sine t. So I anti-differentiate 3 times. So integrate once, integral of 12 plus sine t, 12t minus cosine t plus c1. That's a double prime. Now go back to f prime, integrate again. So 12t squared over 2 minus sine t plus c1t plus c2, 6t squared minus sine t plus c1t plus c2. And now integrate again, f of t is the integral of 6t squared minus sine t plus c1t plus c2. That's 6t cubed over 3. Integral of negative sine t is cosine t plus c1t squared over 2 plus c2t plus c3. Clean it up, 2t cubed plus cosine t plus 1/2 c1t squared plus c2t plus c3. And now how do I go from here to here? Well, C1 runs through all real numbers. So if C1 runs through all real numbers, 1/2 C1 also runs through all real numbers. So I can just drop the half. So 2t cubed plus cosine t plus c1t squared plus c2t plus c3. In actuality, when I take the third derivative, all these 3 guys will drop out. All right, after the first derivative, that drops out. After the second derivative, that drops out. After the third derivative, that drops out, right? If you take one derivative, you're down to t. Second derivative, you're down to a constant. Third derivative, it's nothing. Okay, so the only thing of substance is this thing. So if you take the triple derivative of this, you got what, 6t squared, and then what, 12t, and then 12. And the third derivative of cosine is negative sine, negative cosine, sine. Yeah, it works. 41, this time they give me other conditions whereby I can find the c's. So second derivative is this. F of 0 is 3, f prime of 0 is 4. So I integrate once. Integral of sine is negative cosine. Integral of cosine is sine plus c1. Now when I plug in 0, I get 4. So 4 is the answer when I put 0 there and 0 there. Negative cosine 0 is negative 1. Sine of 0 is 0 plus c1. So c1 is 5. So the function now becomes negative cosine theta plus sine theta plus 5. Integrate again. Integral of negative cosine theta plus sine theta plus 5 d theta. Integral of negative cosine is negative sine. Integral of sine is negative cosine. Integral of 5 is 5 theta plus c2. And then they tell me f of 0 is 3. So now 3 is the answer when I plug in 0 here and here and here. So 3 is negative sine 0 minus cosine 0 plus 5 times 0 plus c2. That's nothing. That's nothing. This is minus 1 plus c2. Add 1. So c2 is 4. So final answer, f of theta is negative sine theta minus cosine theta plus 5 theta plus 4. 47, f double prime is x to negative 2. X is greater than 0. F of 1 is 0. F of 2 is 0. Okay, so to go to f prime, I integrate once. Integral of x to negative 2. X is negative 1 over negative 1 plus c1. That's negative 1 over x plus c1. Integrate again to get f of x. That says f of x, sorry. Integral of negative 1 over x plus c1. Okay, integral of negative 1 over x is negative ln absolute value of x plus c1x plus c2. They told me at the beginning that x is greater than 0, so I can drop the bars. Negative ln x plus c1x plus c2. Now, f of 1 is 0. Put a 1 there, put a 1 there, 0 out here. ln 1 is 0, so I have c1 plus c2 equals 0, or c1 equals negative c2. Okay, then I use the other piece of information that f of 2 is 0. So if I plug in 2 and 2, 0 is negative ln 2 plus 2c1 plus c2, or ln 2 is 2c1 plus c2. Combine it with 0 equals c1 plus c2. I multiply the second equation by negative 1. Add them up. c1 is natural log of 2. Since c2 and c1 are opposite, c2 is negative ln 2. So final answer, f of x is negative ln x plus c1x, which is x ln 2, and then plus c2, which is negative ln 2. So there we go. Finally, for 63 and problems like that, you might recall if you have an original function involving distance, the first derivative is velocity, second derivative is acceleration. So we're going to go backwards. If they give me the acceleration, I could integrate once to get the velocity, integrate again for acceleration. So here's 63. A of t is 10 sine t plus 3 cosine t. S of 0 is 0. S of 2 pi is 12. So I integrate once to get the velocity. So I integrate 10 sine t plus 3 cosine t dt. Integral of that is negative 10 cosine t. Integral of that is plus 3 sine t plus c1. Now find s. Integrate again. Negative 10 cosine t plus 3 sine t plus c2. C1 is negative 10 sine t minus 3 cosine t. Integral of c1 is c1t plus c2. Now they tell me s of 0 is 0. So 0 is the answer when I plug in 0 here and 0 here and 0 here. Okay, sine of 0 is 0. That's 0. So 0 equals 0 minus 3 plus 0 plus c2. So c2 is 3. So that's going to be 3. So s of t is negative 10 sine t minus 3 cosine t plus c1t plus 3. And now they tell me s of 2 pi is 12. So when I plug in 2 pi, 12 is the answer when I put 2 pi there, 2 pi there, 2 pi there. So negative 10 sine 2 pi, which is 0, minus 3 cosine 2 pi. Cosine 2 pi is 1, so that's minus 3, plus 2 pi c1 plus 3. These two cancel out. So I have 12 equals 2 pi c1 divided by 2 pi, and c1 is 6 over pi. Plug that back in, and I'm done. So s of t is negative 10 sine t minus 3 cosine t plus c1, 6 over pi t plus 3. Okay, so those are some problems from section 4.9.